Hello everyone. So today we'll visualize the NDVI from the MODIS dataset, and for the study area of your region of interest, like we'll use the FAO datasets for the save file, and we'll call the save file from the FAO datasets. Also, we'll filter it to a particular study area, or let's say a district, uh, and we'll do the analysis. So first we'll call the data sets, like for our case we'll FAO save file data sets. So FAO GAUL, the name is. So second level administrative unit, so that is the data sets from where we'll get the study area. So we'll change it to the FAO dataset. Like now we'll first visualize what contain that particular datasets. For that, we'll use the map.add layer function to add the FAO layer to our map section. After some time, it will visualize all the save file containing particular datasets. Now we'll filter a particular uh, district to do the rest of the analysis. To get the information about that particular district, we need to inspect the metadata information from the save file. So we'll click on the inspector tab, and we'll uh, select a district to visualize. Like for our case, we have randomly selected one, and here the visual the metadata information showing here. Now if you drop down the property section, you will get the all key and the value properties. So it is given in a object, or in Earth Engine form we say it a dictionary format. So in dictionary format, so the districts we want to filter is the admin to name Balaghat, right? So to select a particular district, we use the filtering method, right? Filtering method. So we will create a new variable that is called like district. Now from the main dataset, like FAO, will filter the selected dataset. So the selected district, so we'll use the filter e dot filter dot eq filter. From the eq filter, what it will contain, it will take the property and the name of the particular district. So in our case, the property name is admin2, and the district want to filter is Balaghat. Now, in place of FAO, if we visualize the district now, we'll get the only that particular district, right? So our study area, we have find out our study area. So that is our study area. Okay. Now, next we'll get the NDVI images. So we'll use in that case the MODIS NDVI. So MODIS NDVI. So there are multiple products for the MODIS NDVI, but we'll use the 16-day global NDVI MODIS Terra. So this particular we'll use, or we'll use Aqua Terra 250. So that is a high resolution uh, above all from the MODIS dataset. Now first we'll get the information about that particular datasets, the metadata information. So we'll print the first image, like the image collection, or we'll change it to the MODIS. So the MODIS first method will give us the first image metadata information. Now with that, we'll get the property and all the variable the bands containing. So there are multiple bands in the datasets, but our targeted band is the NDVI band, and there are system index and all the information. So as we get the information about that particular band and all the datasets, it will be easy for us to work with that particular datasets, right? Work with that particular dataset. So now we have checked the metadata information. Now we'll select the variable NDVI equal to, we'll select only the NDVI property. So from MODIS dot select function will select only the NDVI, right? Only we'll select only the NDVI. Now we'll visualize it to our map, right? We'll visualize to our map. See, we have not specify the boundary, so it will visualize for the whole world for the whole time period, right? For the whole time period, like the data set from 2002 up to the recent time period, the data sets available, right? So but we need a particular time period, like the 2002, 2005, 2008, on the particular yearly or particular month image. So for that we'll select through the uh, filter date function, we'll select the particular date image or the particular image for the time period uh, we want to calculate. So here we'll do filtering dot filter date, right? So dot filter date will specify the start date. The start date is 202001. Let's say 01. So it will write written like a year, month, and day. Now we specify the 2021, 01, and 01. So for the 2020, we'll get the image, right? Now uh, we we want a single image that will represent the whole area, so that way we'll get the median image. So all the images will come to the median value, and it will then visualize the particular data set, right? Now I want to clip that to our study area district. Now we'll visualize that particular, right? Okay, we have missed one bracket. So now we will get the particular NDVI for the district for the 2020 median image. If we specify the palette, then we'll get the actual how it will looks like. So we'll get that view, right? We'll get that view. We need to also set the stretch to that particular area, so it looks good, right? So if we recheck it with the satellite view, then we'll get some idea about the accuracy of that particular dataset. So it is pretty accurate, and it is showing correctly the uh, forest area or the non-forested area. So that way we can get the NDVI value. If we want to keep that visualization, so we'll import it and we'll use that particular visualization parameter like NDVI vis, and we'll use it in our map.atlas sections for the visualization parameter, right? And we'll name it to the NDVI image, right? NDVI image. Now uh, here you can see that it will coming actually like this. But if we want to calculate some statistics out of it, then we need to write some few line of code for the statistics, like so we want to get the minimum and maximum value. So for that we need to select the particular like NDVI district image, and we'll get the radius region. With radius region there are few property we need to fill it, like which information will want to calculate, and what are the parameter that will be some parameter are mandatory, some parameter are non-mandatory. So here the scale is 250, we know, right? CR is best effort, so these are not the mandatory parameters. So these are the mandatory parameter, like geography is dist, and the reducer is ee dot reducer, reducer, a lot of reducer. From that we'll select the min max reducer so that we can get the minimum and maximum value all together, right? Reducer, reducer min max. Where is min max? Max, linear regression min max, this is the one. Okay, now we'll print that statistics. So now we'll here get the image of the particular area, the NDVI value, and alongside we'll get the minimum and maximum value for that area, the minimum value and maximum value for the NDVI. But it is not showing as it is expected because we have not scaled it as per the uh, documentation. So we have to scale it to the that particular value to get it actual what how it is look like. So we'll do that. So here we'll multiply that value, multiply the scale value, so that we can get the actual value, right? We have to also need to change the visualization parameter at the scaling factor. Okay, now we'll use the NDVI base. We'll delete the previous one and we'll rename the next one to that particular. So now we'll run it. Hopefully it will swing the correct like the maximum NDVI value is 0.80 and the minimum 0.07. So this is the statistics for the area and this is the image for the 2020. Same way you can calculate for other area, like if you want to calculate for the 2001, the whole year 2001, that will also get the value, or like that will also get the value. So that way you can calculate for any area, uh, it will work.